Hello, this is the second part of 10.2c, and my video stopped, so I'm starting up again. And we had already written the null hypothesis, and so now we're ready for the alternate hypothesis, which is that there is no difference between the two bags. We don't have a hunch in advance in this case, so we're just going to write a not equals and a mu t minus mu w not equals 0, which is saying that there is a difference, some kind of difference between the two. And we saw in the confidence interval that same thing happening, and we'll talk about that when we get down to the conclusion. We do need to define what these parameters mean. So this is almost enough, but not really. We have to say that mu t is the mean bag strength for Target, and mu w is the mean bag strength for Walmart bags. And then because we did a 99% interval in the warm-up, we're going to do alpha is 0.01 just for a change, just to make sure you know how to deal with that. Sometimes alpha is not 0.05. Step 2 is the plan. And what we're learning how to do is a significance test for a difference of two means. The book has a slightly longer name. So the most important words in this are test and difference and means. You've got to have all of that, but if you'd like to try and shorten it even more, you can. We already did the conditions in the warm-up, so I'm not going to do conditions again. I'm going to just say C warm-up or done in the warm-up. So we can skip that because we did it already. And I might do that again on this quiz. Might make you do one of them and then do the second one with the same context so you don't have to check conditions twice. And then step 3, I want to slow down a bit and make sure you know how to do the do stage. So we are going to calculate our test statistic. Actually, I should write that over here to tell you the truth. We're going to do our test statistic. And we're going to do our p-value. And I should say that the plan always includes the name and the conditions. If you didn't know that, write it down. So p-value, we're going to get there by doing t first. The test statistic is called t, and it is, as usual, it's our sample mean difference, which is xt bar minus xw bar minus 0, which comes from my null hypothesis. So this is my sample difference minus my population theoretical hypothetical difference. And then I'm going to divide by the standard error, which is that square root thing with the st squared over nt and sw squared over nw. Notice these are not sigmas because we don't know what sigma is. This piece right here is called the standard error. And there's no square roots in here anywhere because we had square roots and they squared and canceled out. So I want to remind you that we had st over square root of n, and then we squared it back in when we first were making the formula. So if it helps you to see this again, this is the reason why you don't need any square roots in your formula. That's where this came from. So that's a little bit of a sidetrack to remind you that we took two things and did the Pythagorean theorem on them, but those two things had square roots that now have canceled out. All right, so then we're going to plug in the numbers from what we did in the warm-up. And we had the mean x bar was 12.82 for Target, and then for Walmart it was 9.05. I believe these are kilograms. Yep, kilograms of mass that they put in the bag before it broke. Minus 0, which you could skip writing that if you wanted to. And we also in the warm-up found our standard deviation, which was 1.9, and our sample size was very small, 1.4 squared over 6. And so we talked about all of those numbers in the warm-up, and I hope you didn't skip the warm-up because that would make it harder to do this, wouldn't it? So when I take all of this, you could type it all in your calculator if you want, or you could pick up your calculator and do the shortcut, which is my preferred way. I prefer to write this out and then do the shortcut. So stat and tests, and This is a 2-sample t-test, number 4. 2-sample t-test. So I'm going to just say on the calculator, it is a 2-sample t-test. And then you'd have to put in this same information. Notice that these numbers are exactly the same numbers I just reminded you of that we used in the warm-up. I could also use data, so I could put the data in my calculator lists and do it that way, which I didn't do this time, but you could do that. You could go to your list 1 and put the data from the warm-up and do it that way if you like. And then at the bottom, I have to tell it which type of alternate hypothesis I have. Here's the choice of pooled or not. Always say no when the calculator asks you this, and calculate. And it will tell me a whole bunch of stuff. It tells me that my t is 3.68. And it tells me that my p-value, which I actually could get by doing TCDF, right? I could do TCDF of 3.68 and 999. And the DF is that weird thing that the calculator does this long way, and then I'd have to double it. So if I did all of that, the problem is that finding DF is a pain. So yeah, I just prefer to make the calculator do it. The calculator tells me that my P is 0.0074, and it already doubled it for me. I don't have to worry about doubling it if I use the calculator shortcut. This DF comes from that long formula. The calculator uses that long formula that I didn't show you because I don't like it. And I recommend you just write DF. But if you really, really want to fill in what DF is, the calculator tells you DF happens to be 7.25, and it found it with that long thing, right? But I'm saying do it the easy way. If you're choosing to do it without the graphing calculator, or if you don't have a graphing calculator, then you're going to do the conservative approach and use a DF of the smaller one of these, 5 minus 1, and then you'll get a slightly different p-value. I'm just curious how that comes out, but I'm not going to write it down because it might confuse people. So just out of curiosity, if you do the conservative approach, you get 3.68. And, oh wait, that's inverse t. I don't want inverse t. I want TCDF. Let's do that again. TCDF of 3.68 and 999. And if you use the conservative DF, that's 4. And I still would have to double this. And I get 0.0212, which is different. Still going to be a reject. So that's interesting that it's a lot more different than I thought it was going to be. But that's okay. Anyway, already doubled. I prefer the calculator shortcut. I'll just say it that way. Step 4, conclude. We're going to do the same 3 things we normally do. We're going to do justification, decision, and context. So since P is 0.0074, and that is less than 0.01. By the way, if you use the conservative approach, you don't end up rejecting. That's very interesting to me that it came out that way, because I didn't think it would. 0.01 is our alpha, remember. That means we reject the null hypothesis that, and what does the null hypothesis say? That there is no difference. That's my favorite way to write it. That there is no difference in that mean bag strength, because each bag might be different, of course. Oops, strength between Target and Walmart bags. And our confidence interval also confirmed this. The confidence interval showed that it was all positive, and so therefore that means Target bags are stronger. You can also tell that by the positive t-value. So we conclude that there is a difference. That's the statement about the alternate. And you could even add to it by saying Target bags are stronger. significantly stronger. So that's our alternate hypothesis statement at the end. All right, so there is your example of four-step tests. The next lesson, which is 10.2D, is picky details that we're going to finish up in the next set of notes.